In order to learn permutations and combinations, it's very important that we know the product and the sum principle. Let's see what the product principle is. Here we see that there are different paths we can take to reach from A to C. So we can say to reach from A to C, we can go from A to B and B to C. To make it easy, I'll just name each of the path A, B, C, D. So we can either take AB, or we can take AC, or we can take AD. So there are totally 3 ways of reaching from A to C. But if you had something like really complex route like this, can you sit and write each and every combination? It becomes very cumbersome. So what our mathematicians have done is found a simple way to do this. That is called the product principle. What is the product principle? So we see that from A to B there is one route, right? From B to C there are 3 routes or 3 paths. So totally, if you multiply 1 into 3, you will get the total number of ways that you can reach from A to C. This is called the product principle. So you multiply the number of ways to get to B and the number of ways to get from B to C. So let's see with another example so that it becomes clear to you. Okay, so we have to reach from P to R. Tell me the number of ways to reach from P to R. So to reach from P to R, we need to go to P to Q and Q to R. Remember, whenever there is and, it is a multiple sign. So it is, you have 2 ways of reaching from P to Q, and since it is and, you multiply, there are 4 ways of reaching from Q to R. So totally there are 8 ways to reach from P to R. You can actually name each of these paths. See that there are only 8 ways totally to reach from P to R. So this is called the product principle. Then we move on to the sum principle. What is sum principle? So if you see this example, how many ways are there to reach from P to Q? This is not as simple as the previous one, because you see that there are 2 different ways to get from P to Q. One is from P A B Q, the other one is from P C D Q. So to reach from P to Q, you can either take P A B Q, or you can also take P C D Q. So P A B Q we have done, we can use the product principle. You can say there are 1 into 2 into 1 ways to reach from through P A B Q. That is 1 into 2 into 1 ways. That is 2 ways. And P C D Q, again you have 1 into 2 into 1 ways. 1 into 2 into 1. Again 2 ways. So totally there are 4 ways. So if you add these up, you will get the total number of ways. So whenever you have this, or you add these 2 events. So you add this. So here it is 2 plus 2, which is equal to 4 ways. Okay. Let's see with a more complex problem. So now here you have to reach from X to Y. So tell me the total number of paths to reach from X to Y. Okay. So we can either take X, A, B, Y route, or, so here we have an or because it's a different route. This one, this and this. We can take X, C, D, E, Y, or we can take X, F, G, Y route, right? So can you tell me the number of ways we can take X, A, B, Y route? We apply the product principle here, 1 into 2 into 1. So it is 1 into 2 into 1, or which is plus, because there are more number of ways we can go to X, from X to Y. So this is 1 into, there are 2 ways to reach CD, 2 ways to reach DE, and 1. So we have 1 into 2 into 2 into 1 way of reaching X to Y through CDE, or again plus sign. We have 1 into, there are 3 ways, 3 into 1 way of reaching X to Y through FG. So here we see that it is 2 plus 4 plus 3. We see that there are totally 9 ways from X to Y. So another important method of counting is called the box method of counting. So let's see how to do that. How many 2-digit numbers can be formed from 1, 2, 3, 4 without repetition and with repetition? So let's do without repetition. So what they're saying is, like, when you do it without repetition, you cannot have numbers like 1, 1, 2, 2, etc. So let's see how many 2-digit number can be formed. I'll write it down. It's 1, 2, you can do 1, 3, 1, 4. We cannot do 1, 1 because there is no repetition. So you can do 2, 1, there is no 2, 2. So you 2, 3, 2, 4. You have 3, 1, 3, 2, 3, 4, and 4, 1, 4, 2, and 4. So there are totally, if you count it, we can form 12 two-digit numbers using these 4 digits, right? But there is also a simple way to do it, which is called the box method. Let's put 2 box because we need 2-digit numbers. So how many ways can we fill the first digit? We have 1, 2, 3, 4. So any of these numbers can go into the first box. So we have 4 ways of adding the first digit. So once we take away one number from these 4 numbers, we are left with only 3 numbers to fill in the second digit, because we cannot repeat the same digit which has been placed in the first place. So we have 3 more digits. So this, if you multiply, you will get the total number of 2-digit numbers that can be formed using the digits 1, 2, 3, and 4. So let's go to the other section of the problem, with repetition. So what is with repetition? When you say with repetition, it means that we can also add 1, 1, 2, 2, 3, 3, and 4, 4. If you see that there are now 16 2-digit numbers that can be formed. So how do we do it using box method? It's similar to the first method. So you have 4 ways to fill the first place, and if you see the second place, you still have 4 ways to fill the second place, because the digits can be repeated. So there are 16 2-digit numbers that can be formed from 1, 2, 3, 4. I hope you understood this. So let's do one more problem. How many 5-letter words with or without meaning can be formed from word solar? So they're saying without meaning, so it can be any combination of these letters. So let's do the box method. So we need 5-letter word. So 1, 2, 3, 4, 5. So we have these 5 letters, solar. So how many ways can we fill the first place? There are 5 ways. We can use any of these. And they said no letter can be repeated. So we cannot take the same letter what we have used in the first box. So we are left with only 4 letters to fill in the second place. Similarly, 2 letters have been used. We have only 3 letters to fill in the third place, and 2 letters to fill in the fourth place, and 1 letter to fill in the fifth place. So totally we have 5 into 4 into 3 into 2 into 1, which is 120 words that can be formed using the word solar. Let's see one more problem similar to this. How many different car license plates can we create if they start with 2 letters and end with 4 digits? So there are 2 letters and there are 4 digits. So the first 2 are letters from the alphabets. So how many alphabets are there? It can go from A, B, C, D. It can go until Z. You can use any of the letters. So there are 26 letters in an alphabet. So you can fill it with 20. You have 26 ways of filling this first place. And since they've not mentioned whether we can repeat or not repeat the alphabet, we assume that we can repeat the alphabet. So there are again 26 ways of filling the second place. And the next 4 are digits. So how many digits are there? We have 9 digits plus 0. So that makes it 10 digits. So there are 10 ways of filling this. Since the digits can be repeated again, there are 10 ways of filling the next place, 10 and 10. So totally there are 26 into 26 into 10 into 10 into 10 into 10 number of ways that we can do these car license plates. Let me calculate that using a calculator, which is equal to 676 000 676. These are the number of alphanumeric car license plates that we can create using 26 alphabets and 10 digits. So there is one more question. So try to solve this problem and let me know your answers in the comments. Thank you.